on Wednesday, I think the most important exercise throughout the semester, please do not miss the class. During the lab, we are going to create the database that you are going to use for both your exercise lab as well as your project. So I'm not going to allow any local installed the database. For your practice, it's okay, but for your project, you need to use the database, the MySQL database running on your GCP. Okay, so please attend the class on Wednesday, then create your MySQL database. Okay, once you create the MySQL database, you can later delete and recreate based on for your practice, so it's totally fine. So please attend, do not miss the exercise lab on Wednesday. Plus, so since many of students, so most of students, it's the first time to use the GCP. Even though I asked you to practice by yourself, I don't think. Still, there are some students who didn't activate the code and didn't create the project yet, so never ever try. So I'm going to offer, I understand that sometimes it's a little bit afraid to use the new technology or a new platform. I'm going to offer extra exercise. This is optional, it's not mandatory. So if you are available on September 22nd, it's a Friday, so 3 to 5 p.m. we will cover as much as possible on the GCP exercise lab. After prerequisite is you need to activate the coupon code and also you need to create the project. After that, we will cover as much as possible on Friday. This is just the extra exercise lab. So please, you can join the extra exercise lab on Friday if you believe you need more practice on the GCP. Okay? But that will not cover the creating MySQL database. MySQL database for database lab as a prerequisite to start the SQL practice later. So please think about to join the GCP. This is the option. This is not only for this class. It's for all my teaching class, operating system, data mining, as well as this class. So we will cover as much the exercise lab as possible on Friday. Okay. But we will not start from the activating the coupon code. So also you should create the project, at least one project for your practice at the time. Any question regarding to the exercise lab? Okay, so please try. Just try. Nobody blame you, even though you learn even the Google likes the student to try the stupid thing. Okay, you can upload a huge amount of data, learn the BigQuery or the API. Then if there is an error, that will be automatically reported to the GCP team. So don't worry about something messed up. You can just recreate. Okay? Yes.
As you know, almost the past, the first time that we use GCP.
Even it's my first time.
Yeah. So my question is, can we get tutorial online? Did you recommend any website that?
So this is the compiled exercise lab. All the details you can go to the cloud.google.com. There are very nice, very well organized. You don't have to purchase any book. You don't have to. Most of them, 100%, they are just copying and pasting from the Google Cloud website. Google Cloud website, even they provide a quick tutorial. You can just follow the click. Even they show if you do not know which menu you need to click, it shows the highlight. Have you ever tried start the tutorial? Why don't you try first, okay? So that is the best way to learn the GCP. Yes?
What about if we create our database, for example, use one server in order to create it? Is there any way to, through the GCP, in order to expect this database?
I don't understand exactly your question, but my understanding is whether we can create the database then access from any other.
No.
No.
I mean, if I create my database on, for example, one.
So for your individual practice, it doesn't matter whether you create the local database, you pay the $1,000, so it doesn't matter. But for our exercise lab and for grading of the project, we are going to check your database running on GCP. Okay? But for your practice, it doesn't matter. You can install whether you can process. Definitely it's fine. But for lab and class activity, it's running on the GCP. Okay, then we have the homework chapter 4 due on the September 22nd. I'm not going to, sometimes I forgot to mention, so it's your responsibility to check the 1 or 2 times on the canvas. It will show something, the upcoming event. Because it's already scheduled. If you want, you can do the homework in advance. Do not wait until the last minute to submit it. Okay, so we are going to continue the lecture. For today, we are going to start the relational data model. Before that, I think we'd better quickly review what we have.
Excuse me, Professor.
Don't forget to submit the homework who missed the last time. Okay, after class. Last time I forgot to pick up this one, but luckily it was here.
Excuse me,
Yes.
Professor. We do have something that we need to submit on 20th of September, which is of GCP. What do we need to submit in that?
Regarding to, I think that is assigned by the GA. Please contact the GA.
Okay.
So GA has a responsibility to assign any homework which I do not know. Okay, during the lab or during the something, most of the time is a lab, the GA will assign something homework to submit. But if you attend, okay, probably you know. So, but most of the time, if you miss, did you miss the last time?
No.
But she
But
didn't mention?
No.
So why don't you email to her, okay? That can be the future homework, okay? The GA will take care of such a homework regarding to the lab or the other extra, okay? Any other question? Okay, so last time I really hurry up to explain about the ER for the first exercise lab regarding to the Irwin software. Do I need to use Irwin software for my project? No, it's just one of the options. So also, I didn't attend during the labs was not easy to. Don't worry. So that is one of the software. So when you download the app and try the certain app on your phone, do you need to take the training course? Mostly it's a straightforward, easy user interface. So nowadays, most of such a modeling tool is very user friendly to use any of them. Just try. Okay, you are not the high school student. You are not freshman. So most of the students are the graduate student. You are able to catch up to understand how to use the software. Okay, Irwin is one of the software. Even there are huge, rich amount of the functionality. So if you want to know more about the database design or database architect, the project management, you can try. So probably GA cover, I think, the less than 5% of the functionality provided by the Irwin software. Okay, just try. So, but if your preference may be different, varied. So I try to use the video. I have used another software, so it's totally fine to use the other software for your case. So to the modeling, conceptual modeling. At that time, before that, we talked about the specialization and generalization, super and subclasses of the EER modeling. Unfortunately, later you will realize that relational database model that we are going to learn and use, cannot support such a super and subclass object-oriented concept. So because of that, we need to differentiate the superclass and subclasses concept in data model. It's a conceptual model. So for example, this is how many entity here? One. But we have employee superclass entity, employee entity, and there are 3 subclasses. Employee entity is a part of employee entity. However, to represent such a relationship, there are 2 types of such a relationship among the subclasses: disjoint and overlap. So if you allow only one of this, that's the disjoint. If you allow the multiple joint, like the secretary and technician, then it's the overlap. We can use the O instead of D. And also sometimes there are single line and double line. Single line means always it's a partial, optional, which means there might be employees who are not in secretary, who are not in technician, who are not in engineer, just a general employee. At the time you can use a single line. However, if you the first employee should be one of these, at least one of these. It can be multiple in case of overlap, so that it will be double line. So that is the full participation. So we will see such a difference later. Why it affect the database modeling. Okay. Then how in this case what is the key attribute in terms of ER modeling? Only SSN underline. What about the secretary? What is the SSN? What is the key attribute of the secretary? SSN, because it's an inherit. So it's just a simple object-oriented concept. All the characteristics of the superclass will be automatically inherited to the each subclasses. This is one super and subclasses. So we have seen this one, and don't worry about whether this is a generalization or specialization. So while you are modeling this, it can be either the generalization or specialization. For example, I found the employee first, then realized that there are 3 subclasses. It's a top-down, it's a specialization. Or it can be, I have a secretary entity, technician entity, engineer entity. Then realize that they have common information like that, so you define the employee. That is a bottom-to-up generalization process. However, in terms of data modeling and database modeling, there is no difference between generalization and specialization. It's just the super and subclasses. Even database modeling, we do not have such a concept. Later we will see. Okay, so this is another example of the super and subclasses. How many entities? One entity. And what is the key of manufactured part?
Part number.
And so on. Is it overlap or disjoint? Overlap means there might be part belongs to manufactured and purchased part. That makes sense. So I have a part. This is manufactured, not out of the market, and also I purchase that part. What about the part which are not manufactured, which are not the purchased? Is it possible? No. Oh, it should be at least one of these. Okay. Then, at that time, if hierarchy, there are special, the different types of the super and super. You can see we have the example of, yes. It looks like from here to here, like the one. Looks like the tree structure, right? So when we see the super and subclasses, okay, how many superclass for each subclass? One. Okay. At that time, it's a hierarchy. It's a hierarchy. Then, so this forms what? Tree structure. How many parents? One parent. I mean the father and mother, your mom and dad. So that is the family tree structure. That is a tree structure. However, if you allow multiple superclass, one or more, the superclass, it is called the letters. For example, this is one. Engineering manager, how many inheritance? 1, 2, 3. How many super and subclass relationship? 1, 2, 3, 4, 5, 6. Total 6 super and subclass relationship. In total, only one entity employed, but inside the, for example, engineering manager inherit. There are 3 inheritance in this. So at that time, it's called the lattice structure, but it's not the important concept. There's another. This one is slightly more important than the other. So this is called the categories or union type. Let's take a look at the example. So let's first see the owner owns registered vehicle. It's a simple 2 entity and 1 relationship. Okay, the owner owns the registered vehicle. It's a many-to-many relationship, which means one owner owns multiple vehicles. One vehicle owned by the many owners. Okay, that makes sense. Then at that time, when many owners, different types of owner. Okay, for example, when you purchase a car, if you pay all the price, it will be yours. Solely you are this sole owner, only owner. But most of the time, down pay and get the loan from the bank. So your bank is another owner. Who has the priority? Bank has the priority, which means if you bankrupt, so like the foreclosed, then bank first take the price, the money from your vehicle, like the house, if you have the mortgage. Then if there is any remainder, then you can take the other. So your bank has the higher priority. Sometimes your car company, like the Honda, Toyota, they provide manufacturer financing service. So let's say there are 3 types of owner. Person, bank, company. At this time, these are the super classes. Okay? Then inherit to the owner. It's a subclass. It's not the super and subclasses, actually multiple superclass. But they are the same, going to the same inheritance. This is different from the letters. Like the letters is 1, 2, 3. Okay, it's a separate super and subclass. This is 1 super and subclass. Where is that? 1 super and subclasses, but it's eventually combined. At this time, each of superclass is called category, type of owner. Okay, this is a type of owner. Problem is, each superclass has their own key. Like the person has the driver license number, bank is the B name, and company is the C name. What about the owner? Owner inherit all of this. So which one we need to use? They are different. Because of that, most of the time we will create additional artificial key, which is called the surrogate key. Okay? So for example, the owner ID, we create another owner. Such a surrogate key used a lot in our real database. Later we will talk about more. Think about if you already create the database in your program language, how did you create the table? Customer ID. Item ID. Transaction ID. I didn't find any key attribute. Instead, just create ID, unique number, sequence number. That is mostly surrogate key, artificial key. So for better performance, you can create such the artificial key or surrogate key intentionally. So we can use such an approach for the owner. Okay, this is called the union type, or just think about it's kind of category of the attribute, the entity. Okay. Then it's the same thing for registered vehicle. So type of registered vehicle is a car and truck. And at that time we can use the U to represent the relationship. Okay. Superclass and subclass. Multiple superclass and one the subclass. It's a union type. Okay. That's the most of the thing in the EER model. Then this is the formal definition of the ER. One thing, So we already discussed most of the thing, but I'd like to ask a question. What is the formal means here? So-
Technical definition.
Technical definition, which means so far we talk about informal definition, non-technical definition. The formal dress. Nice. So this is a nice, neat definition, and so far Professor Lee used the ugly definition. So when we talk about the formal in computer science, always replace the formal by mathematics. Okay? It's a math equation. It's a mathematical definition. So you will see a lot of times using such a format. Format means the mathematical approach. Formal definition. Formal, something is a mathematical way. The best way to prove anything, like the definition, theorem, corollary, and anything in mathematics, science, any types of science, including computer science, geology science, whatever the science, best way to prove your idea is experiment, coding, simulation. No, it's the mathematics. If you can prove your idea, mathematics, that's it. You don't have to code. Code is the additional proof. Okay? In case we cannot prove by mathematics. Mathematics is why? Math. Think about the Pythagorean theorem. What is the Pythagorean theorem? In case of a right triangle, the c square is equal to a square plus b square. Is it true in the other country? Like India or China, South Korea? Yes, that's true. And what about the universe? If you go to the moon, is it true? Yes. What about the alien? Is it true? Even though probably name is not Pythagorean, it is true. Why? Math is the universal. Okay? It's a universal, which means it's always true. However, the problem is not always we can use a mathematics or equation to prove your idea. For example, performance, which one is better than the other? Mathematically, you can show, but it's not theorem. Theorem means it's 100% true for given condition, but it is very hard. Or network. So instead, we code, make the program, and the simulation, demonstrate, experiment, empirical result. Same thing in the other science. So other biology, they did something experimental, laboratory, instead of the mathematical proof. So this, especially the computer science, is closely related to the mathematics because actually comparing to other science subject, computer science is very young. Okay, like 40, 50 years. Okay, the first computer science major department is not that old. So think about how old each university is. It's 200, 300, and think about check the history of the computer science department. It's not that old. Most of them start from the mathematics department. Okay, so because of that, many of the concepts discussed in the computer science from the mathematics approach. Some of the computer science textbook is just like the mathematics textbook. So if you are interested in the deep learning, have you ever heard about deep learning? If you read some of the textbook, deep learning, it's not computer science. There is no coding. Okay, only mathematics. Okay, so that is the formal definition. From time to time, we will use the formal definition here. We will skip that. The problem, it looks like hard to understand. But once you get used, this is much easier. Okay, so please, if you are interested in especially the thesis option on the master, the graduation option, or higher degree like the PhD, or the researcher or the laboratory to think about such a getting used to the formal definition. Okay, I'm going to skip this part. It doesn't mean this is not important. No, it's nowadays getting more important. Like eventually, when we have a data, our goal is to use such a data. For what? It was just to pick up the information that I want. Nowadays, it will be kind of inference, whether we can find something important. Why? When we discuss about the definition of information and definition of the data, some of the students, my definition was from the information we try to collect the important information, that is the data. But one of the students mentioned information is like the output of the data processing, kind of knowledge. So that is true. So we eventually nowadays is kind of you heard about the AI, okay, machine learning. Why we need such a processing? So data processing, data accessing, data processing itself is not enough. We need to such a intelligent, the knowledge. So the next thing is once we get the knowledge, how to manage the knowledge. So knowledge management, one of the way is ontology. Okay? Why don't you just keep your mind? Any question? Okay, so then next thing is chapter 5. So what is this?
Cloud.
It's a cloud. In our class, this is information. So from the information, so our goal is to create the database and database system using DBMS. In our case, we are going to use the RDBMS, specifically MySQL database. Then using this, so we are going to create application program that use the database. Overall, this is called the database system. That's our goal. Then huge gap from information to this one. So first, we need to do the step by step. So we already did. From this one, collect some of the related information and select the attribute and define the entity and sometimes define such a relationship, okay? And find the key attribute and so on. This is what?
Concept.
Modeling. Modeling what? Conceptual modeling. There are many different types of conceptual modeling. Among them, we use the most popular one,
Yeah.
ER. If we consider enhanced extended part like the super and subclasses, the concept, this is called the ER model. It's a conceptual model. Logical, sometimes it's called a logical model. Is it related to the computer science? No. It's just a general idea. This can be useful in our daily life also. If you arrange or if you organize your room, so you don't want to mess up the operating system class, database class together. Instead, you pile up operating system class, the textbook and the material. And this is only for database class, something like that. Same idea. So you can use such a then. If they are related, you can manage such a related, like the grade, course, and the student, and the grade, and so on. So we can manage we can organize. In other words, it's a structure, more structure. Okay. Then what about this one and the database system, DBMS? Still found huge gap. Okay. This one, as I said, is for general purpose, not database system only. We need to get close to this one. It's like so very far. We need to get close to step by step. So next thing is when we develop the DBMS system. By the way, DBMS. Can you develop the DBMS?
No.
Yes. No?
I'm not sure.
You can do that. It's a programming. So you are doing programming. Then if there are requirements, you can do that. Actually, several years ago, in this class, when the database class is separated by the database design for undergraduate, it's actually not undergraduate, it's a 450, and this was the advanced database class. So in this class, we developed the relational database management system. The designing is a 450, and 550 is for developing the database system. Then we can actually develop such a software. Based on what? We need to have the requirement. What kind of requirement? We need to have the database model. What is a model? It's a concept. Okay? It's a set of rules. If somebody provides a set of rules, you can code it. You already took the programming class. That will be your programming, application programming, that will be database management system. Okay? But they need something, the rule and concept or constraint that will call the database model. There are different types of database model. For example, I'd like to manage a banking system. Bank has branch and branch 2, branch 3. Each branch has loan, saving, and customer. For the customer, company, and the individual, and so on. What about this one? This one has exactly the same thing. And this one has exactly the same thing. Then, when I access the information about the customer lead, first starting from here, then which branch, branch 1, customer, then customer, and customer 1. Find it. When I try to find another customer in branch 2, I'm going to this way, next level. Or if I access the loan amount, going to this way or this way. This is called tree structure, hierarchical database. If we organize our banking database in this rule, it is called the hierarchical database model. Still used. Very fast and reliable. Okay? What we need to do is the next level. We can get the full benefit of tree structure that you learn in your freshman or undergraduate, right? So tree structure. Next. Problem? IBM used this one. And also operating system used this structure for the file, ISAM file, and so on. Then, problem?
Takes more time.
More time is fast to access.
No, traversing.
Traverse, in other words, I have the account, the loan account here, loan account here, loan account here. I'd like to know some of kind of balance overall in this bank. We need to visit all of them. Sometimes it is not easy for certain the condition of the retriever.